Okay, so welcome everyone. So I didn't introduce myself at the beginning, so I'm Dan Eakins. I'm the Director of Graduate Studies here in the department. And what I want to do in the next, I'd say half an hour or so, is to make the case for why you should consider doing a postgraduate degree here in Oxford. And then what I would like to do is then, if I've made that case well enough, I'll tell you about the admissions process, I'll tell you what opportunities there are for funding, so that you might consider then hopefully putting in your application to us. Okay, so that's a little bit more detail about what I'll go into, but as I said, I'll try to make a case, and then I'll give you some instructions about how to craft your application to us and what that application might be looking for. Okay. Okay, so why might you be here, right? So I think if I were to ask each of you, what brought you in the room today, I think you'd all have your own personal reasons, but they tend to be categorized into a couple different buckets, if you like. So those of you that are still in the final years of doing your undergraduate degree, you will start entering a phase at your university where you'll start doing third and fourth year projects, for example. And that's when you begin to start to apply the general tools and techniques and learning that you've undertaken over the last 3 or so years to start answering open-ended questions, right? So this might be a research project which you're now beginning to start probe and see how the tools that you've developed actually can be used to solve quite meaningful problems, right? And so you might find that quite stimulating. Those of you that have left university, you did your undergraduate degree before, and now you've been in employment for a bit of time, might have experienced that actually you feel there's a need to upskill, or there might be maybe a ceiling that you'd like to break through if you want to start being in command a bit more of the direction of your own application of your skills. And that's really with the differentiation between an undergraduate degree and a postgraduate degree. With an undergraduate degree, we teach you a broad set of skills and understanding across a very wide discipline, and that allows you to solve a broad set of engineering problems. But if you would like to actually get a bit closer to the materials, the physics, the mechanics in some cases of certain problems, and actually pose the questions yourself and direct the course of that research and how those questions are addressed, that's really what a postgraduate degree allows you to do. It allows you to develop deep knowledge in a specific field and a specific topic, and allows you to be in control in a way of posing how you would address that question, and in many cases directing teams, right? So it allows you to rise up within your research organization, whether that be in industry, academia, or in government, and to actually be the one that's potentially steering and leading that research program. It allows you to push the boundaries of knowledge, contribute towards the generation of new ideas, and as we said, it allows you to open up new job prospects and career pathways. Now what that might look like is, in three different buckets, if you like. In academia, there are some levels in academia which are frozen out if you don't have a postgraduate degree. So if you want to go on and you see yourself, envisage yourself teaching, becoming a professor in some cases, then you will need a postgraduate degree to get there. You need a PhD or a DPhil in our case. In industry, you can be a specialist, a team, a group leader. You can rise up into higher levels of responsibility within industry. And in some cases, maybe not joining industry, but in fact founding your own company. And I'll show you in a moment that this is actually a destination for many of our graduates here, is actually being co-founders of spin-out companies. And in government, there's many different career paths in government, but for example, you can be policy officers, analysts, technical advisors, highly respected for your deep knowledge in a particular topic. And in fact, you could even be an R&D scientist working with one of the many national labs in the country, so STFC, for example. Okay, and actually, you're not frozen into any one of these lanes, and it's very common for very highly educated, highly technical people to be able to move between these different career paths as their interests move around, right? Okay. But now let me make the case for why you should consider doing a degree here in Oxford. So Oxford has a lot to offer, as Clive will have just said. We're quite a good university in terms of ranking. He's already said that we're the second highest engineering department as ranked by QS recently. If you're familiar with the REF exercise, the Research Excellence Foundation exercise, this is where a panel of our peers then assessed the research quality of a university on the basis of the papers that we publish. And there's rankings, and 4-star is the highest ranking. And what that means, as it says here, is it's world leading. It means our research impacts. It's read by the rest of the world, it impacts the rest of the world, and it moves thought and ideas, right? And 71% of the papers that are published within this department were rated 4-star in the last ref exercise, and we output about 1,000 papers a year collectively as a department, right? Now you might think that that's really great, you know, that's professors doing the professing thing that they do, but actually who writes those papers are you. It's the postgraduate students that are actually doing the research, conducting the experiments, running the simulations, analyzing the data, drafting, writing, revising, and then, yes, with a rubber stamp of approval from the professor, publishing these papers. So actually that success is very much the success of our postgraduate students, right? So they're operating at the highest level that you possibly can in terms of impacting thought within the world. And we also have, in terms of measures of esteem, our professors and our research staff are selected and highly competitive for some of the highest honors in terms of fellowships within Royal Societies and Royal Academy of Engineering. So we have over 40 research fellows and chairs in the department that are, again, that are starting to really influence the direction of research within their own respective areas. And as again, another measure is that we, you know, in engineering, we do applied science, right? So the objective is for us to build and influence the course of engineering in the world and to provide products and new solutions to the community, right? And so one measure of that is producing spin-out companies. These are translating ideas from fundamental science, low technology readiness level, if you're familiar with those terminologies, up to products that then could be commercialized. And so our department has resulted in over 45 spin-out companies, some of them which you might have heard and seen in the news in recent years. First Light Fusion is one, but there's many if you look on our website, which have made real big, you know, certain impacts. Certainly during the pandemic and the COVID crisis, there were quite a few spin-out companies directly targeting ventilation and other sort of health benefits. Okay. Why else might you choose Oxford? Well, Clive has already said this, but one of the key strengths of this department is the fact that it is a general engineering department, right? So we have 8 panels, and you'll have an opportunity to hear from panel specialists in the afternoon. They'll tell you more specifically what they're doing in their respective research disciplines. But the general engineering approach means that there's terrific opportunity for collaboration. And in fact, the academics that are in our department, over 130 academics, don't necessarily only sit in one panel. In many cases, they span multiple panels because their research is at the interfaces, and it's the interfaces which are growing over time, especially with the rise and importance of data-driven methods. Information engineering is actually now becoming more infused in all the other panels. But the other opportunity is that you, as a student, might have co-supervisors that sit in different panels, and that might be essential for the specific type of research that you'd be doing, which needs to draw on materials and mechanics information, as well as Clive said, thermofluids, looking at heat transfer problems and fluid structure interaction, right? And so this general engineering structure within our department does allow for those cross-fertilization of ideas and actually the identification of the right expertise to tackle the most challenging problems. And as I said, do book yourself into having a look at and listening to some of the panel talks this afternoon. That's how you're going to really find out about the exciting research that they do. Why else? Well, so Oxford has amazing facilities over many decades. In fact, there's been investment into facilities that are in our respective research institutes, and these represent national capabilities. So decades upon decades of investment from industry as well as from research council funding allows us to operate really sophisticated equipment that would be very difficult to replicate anywhere else. And so what you have in the upper right-hand side, I'm not going to go through all of these, of course, but you know, this is over at the OTI, the Oxford Thermal Fluids Institute. You've got gas turbine test rigs, hypersonic tunnels, ORI, which this lab is actually open today. So again, I encourage you during the break to head over to OTI when they're open, have a look at some of the robotic research that they're doing, and a range of other facilities that we have within the university. And there's many others. So every PI sits within an orbit of capability, whether that's physical lab space, infrastructure, wet lab, or whether that's compute, right? So there's even soft stuff that I've not even put up here in terms of, codes, methodologies, algorithms, which very difficult to put into a picture, but again, are world leading in terms of AI, right? We also, this is actually brand new, from this year going forward, we recognize that we want to make sure that every student that comes into our department is not prevented from doing their research because of funding, right? Now this is not something that was in place before. Some students who apply on the studentship would have good research funding, others that might be self-funded wouldn't necessarily have funding. And so we've made a decision in the department that we would ensure that every student has access to a postgraduate student support fund that can fund computing hardware, equipment, consumables, that make sure that they can actually do meaningful research within their lab environment or within their group, and also travel funds to make sure that they can go to meetings and they can they can get awards, right? They can go to optics conferences, or they can be recognized for the excellent research that they do in other venues, getting poster awards, presentation awards, for example. Right? And that's also present in respective colleges, and that's actually a unique feature of Oxford as well that I'll get into in just a moment, is that colleges also then will provide opportunities for you to bid for funding or to make cases for assistance in terms of going to conferences or traveling, assistance with language courses or book grants, in fact, if you need to purchase other materials. Okay. Oxford's also quite unique in the sense that we do have opportunities for both small group teaching and large group teaching. Because there is that college system, the expectation is that we teach in very small groups, 3 to 4 students, depending upon the college, but also when you're demonstrating for the department, you're teaching in much larger groups. So if you, in the back of your mind, are thinking that your destination lies in academia, then getting that first exposure to being able to communicate science, to be able to break problems apart and actually help someone who's actually going through what you went through a few years ago, that's a really important skill, and that can be done through many different modes. So I've mentioned demonstrating, so you can demonstrate for undergraduate labs, you can teach for a college in small groups, you can also help us with outreach. So we do run unique summer schools, and you can start trying to encourage students to think of university, think of STEM as a viable destination for them. And things like this, open days, so lectures and demonstrations. We'll have demonstrations in the foyer of the IEB, and those will be run by potentially students as well. The other thing about Oxford is that we have a very strong community. Right? That community is both in the department, as I said, is this broad disciplines spread across 8 panels, where you have that community of engineers that have that multidisciplinary environment, but also because of the collegiate system, outside of engineering, you'll then be interfacing and able to interface with the researchers in entirely different fields, outside of maths, physics, and life sciences, even in the humanities department as well. And the collegiate system offers then access to unique spaces that we don't have in the department necessarily, so libraries, study areas, and dining areas. Social, this is a social hub. This is where you'll be, if you're so inclined, you can participate in blues, sports, rowing, for example, which is quite popular. But also within the department, and actually I don't want to steal too much information from Jack's talk, but we also have a structure here that allows the students to communicate and provide feedback to the department. So if the experience needs some help, or we need to provide some more attention or resources to students, there is actually a good forum where the students meet with myself and others in the Graduate Studies office to try to help make that experience better for students. So there's a very vibrant and active community both within and outside engineering here at Oxford. And probably the most important metric is you're not meant to be a graduate student forever, so what do you do beyond Oxford? What does Oxford help you do? Well, we had a survey of former postgraduate students. This was a graduate outcomes survey, and we asked them 15 months after they received their degree from us, their postgraduate degree, were they in employment, right? I mean, that's an important metric, and we noticed that about 80% reported that yes, they were indeed in paid work. and only 3% were unemployed, right? So what's the gap? The gap is actually going to further training and doing other things, not being unemployed. And so they're able to get work, and actually 90%, and this is probably the most satisfying for us, is that 90% thought that their work was meaningful and actually used the skills that they developed here and trained here while here at Oxford. And they were in a wide range of destinations. So, some of them were research fellows sponsored by the Royal Society and other academic groups. There were also then founders from various companies, Ground Truth Labs, Oxite, Carbon 13, who we'll hear from. So the co-founder from Carbon 13 will be speaking today and telling you about his experience. And YASA as well, that's a spin out from ours. And also going to large engineering firms, Arup and Rolls-Royce, which is a very prominent group that we work with here in Oxford. Okay. So, Oxford is not a bad place to do a postgraduate degree, and it sets you up for the future. So what courses do we offer that you might be interested in? So we have, on the left-hand side, this is research-based courses. So our research degrees, where you are tackling advanced study of current problems, is our DPhil in engineering science. DPhil is just the Oxford name for PhD. It's equivalent, right? Employers will treat it the same. And they're in two modes, 3 to 4 years, or this can also be done part-time, 6 to 8 years if that's more convenient. And then we also have a shorter version of the DPhil, much the same, still doing research, and it's just a little bit more abbreviated. It's only 2 to 3 years. But in terms of the journey, it looks the same. It's just that the amount of work you do is a little bit less. And then we also have Centres for Doctoral Training. These are structures which are funded by UKRI, the research councils, around strategic themes, right? This is where the UK research councils have said, we want to see a cohort of students which are training in this area because we think it's of national importance. And so we have a number of CDTs, and we've got the Autonomous Machines and Systems CDT, Engineering Biology, which is a new CDT, Robotics and AI for Net Zero, and Intelligent Earth, right? And I'll say a little bit about them, why they set themselves apart, but in terms of funding. But this is where you actually do a bit of a hybrid. There's a first year often that's very top material, right? So you can get everybody up to the same speed, and then you go off and do an individual research project for about 3 years. Okay. But we also offer top masters. So these are MScs, master's courses, which are coursework based, but they do culminate in a dissertation. So you will be doing modules with small groups, 4 to 6 people, but towards the end of that course, then you will be doing a very small project or short project, which culminates in a dissertation. So one of our most popular, and actually most popular because it's the only MSc at the moment that we offer, is the MSc in Energy Systems. So this can be done in a number of different modes, single year, full-time, or 2 to 3 years part-time. But we also have a number of other MScs which are being brought forward and will become available the next year. MSc in Autonomous Robotics, this is still going through final approvals, but everything looks like it will be offered this coming year. And then we have another one which I can't mention, but we will be growing the number of MScs that we offer. So if your style is more wanting to do a top masters, then we do have a number of courses that are becoming available. Okay, but focusing on PGR, so what happens while you're on a PGR course? And I'll just take for a moment a DPhil, right? So DPhil and an MRes, a master's degree. The first year is largely the same. The first year you are doing a literature review, right? We all come from different backgrounds in terms of what we learned for undergraduate, so we will have to get up to speed, each of us. And so you'll be looking into the literature to find out, and I usually say this to my students, you're trying to paint the picture of the whole, right? And that's quite difficult to do. In other words, what has been done and where is the boundary between known and unknown? And that whole is usually what you're saying I'm going to try to fill over the next 2 years or next 4 years, right? So that's what the literature review is for. You're trying to identify a clear research question that is clearly novel, meaning can't have been done before. And also is worth doing, right? It needs to be impactful, right? You're also then spending that first year developing key skills and proficiencies, because we can't just be sitting and reading all day. We also might need to be learning how to use microscopes, learning how to perform certain specific experiments, learning how to code, possibly run certain software that the group has already developed, so you're getting up to speed so that you can start to do meaningful research. And then there's also the social aspect that you need to be attending your group meetings, meeting with your supervisors, attending seminars, observing how maybe second year, third year, fourth year students are operating, so that you can see how to emulate that as you start to grow through your degree. And in terms of I guess a timeline, the big difference between undergraduate and postgraduate is there's very little assessment along the way, formative assessment, that is, right? There's only two gateways, if you like to think of it. There's a gateway which is about a year into your degree, and this is what you're preparing for in your first year. And the purpose of that gateway is just to make sure that you have a real clear idea of what the question is, and as important, that you've got a plausible idea of how to conduct research to address that question, right? So you need to basically have an idea of where is the destination that you want to go, and that's assessed by a couple of academics in the department, and really it's for feedback. It's just to say, yep, we think you've got a good idea of what you're doing, or might need a little bit of thought in this area. But it's just to make sure that nudge gets you in the right direction, so that in 2 years or 4 years' time, you'll actually result in a very nice degree at the end. But the other thing we need you to do as well is to build up your professional skills, right? Because it's fine to get narrow, and that's what we do on a postgraduate degree. We get very narrow and deep in a certain topic, but we also need to be professional engineers. And part of being a professional engineer is being able to communicate science to a broad group, right? To a broad audience, whether that is other people within your research institution, or whether that's to the public, right? And those are through professional skills. And so what's also requested in the first year is when you go and present your ideas for what you want to do for the following years, you also need to show that you've looked into, taken some courses on improving and strengthening your communication skills. And this is to allow you to, yes, I guess, present in a very, not very intimidating environment, so within your peers, within your group meeting, but then what might seem a little bit awkward to us initially, presenting at workshops and conferences where the audience is a bit more unknown, but they will be technically in your area. And then in some cases, some of us actually really enjoy giving media interviews. I'm not one, but there are those that do, and it is worth taking the training, because there are things that happen here that shouldn't happen here, and that's what the media training is for. So these are professional skills which are open to all students, and then we encourage that you take some mixture of those that excite you, and then that's what we'd want to see after that first year. Okay, what happens after the first year? Well, the following years is you doing your research. So whatever your research topic is, you may be carrying out measurements, you may be running calculations, you may be analyzing data, to start to chip away at the problem. And that's the important thing. It's a problem that is meaningful is a problem that takes 3 years, right? With a little bit of fat on the end to write things up. And so you're going to be chipping away at it, and sometimes it's not going to go well, so you need to revise things. So also what's part of the following years is to consider the results that you are obtaining, revise your methods and approach if that's needed, which shows that critical thinking. Is it going the direction that I think it needs to go? Am I actually uncovering truths that I said I was going to, and is this going to result in a DPhil at the end, or a master's in the end? And then also very, very important is being able to communicate those findings through a variety of different means, through talks, internal, external talks, through papers, writing up papers, and eventually in your dissertation. Okay. In terms of a formative assessment, the only other assessment that there is on course is really a second milestone. This is only for the DPhil, mind you. There will be a second milestone 1 year before submitting, and all that is just to check your course, right? Say, okay, this is what you said you were going to do in your transfer. Now let's see how you've done, and if there's any sort of gotchas, we want to point that out while there's still time for you to make some adjustments, okay? And that's what that is just to say, basically, yep, you're ready to go ahead and finish, continue what you're doing and write up and you should be fine, right? So that's just a stamp of approval there. So only two bits of assessment while you're on course, where everything else is then just operating and growing as a more independent and confident researcher. Okay, so how do you go about applying? Well, if you go to our pages and you actually look at the university graduate page, you can look at courses by department, and if you click on engineering science, you can see all the courses that we do offer, and the list goes quite a bit longer. So you can see here we have this autonomous intelligent machines and systems, that CDT I mentioned. We have our energy systems on the different modes of study, full-time to part-time, and then eventually down here you see the engineering science DPhil, a full-time course. But there's, as I said, there's a couple more as you go down. Really important is when you go to that course page, do read it, do look at what the entry requirements are, because they do require a few things, and these things do take a bit of time to put together. And as I'll say, there is some thought that needs to be made around when you submit things, and I'll spend some time on that in just a moment. But these will require usually, a topic. You need to find a supervisor, someone that wants to look after your research and actually champion your research while you're on course. Your CV, transcripts, reference letters, and research proposals. If you were to put in a CDT application, these are very specific. We already know what the subject is, so you don't really need to put a research proposal in. They're more looking for a research statement. But it will vary from CDT to CDT. They will clearly outline what they're expecting. And so it's really important just to check the how to apply pages for the respective course you're interested in, just to see what the requirements are. Okay. I'm not going to spend too much time on this because it might seem a bit obvious. But the research topic and title, okay, well, what would you like to do research on, right? So we have received applications that just say DPhil, right? Bit general, makes it really difficult for us to then, if you haven't also put a supervisor in, to find what supervisor would potentially consider application. So try to make it topical, try to make it descriptive of what you'd like to do. It's also really important that you check that the research that you want to do is something that we can support in the department. We're a big department, as Clive says. We've got great turnover, we've got lots of staff, but we don't do everything actually in engineering in this department. We can't afford to. So we are quite specialists around certain topics, but there are things that we cannot do. We can't do metal-based 3D printing, for example. There are other universities that are specializing in that. So we need to check that actually can be supported, because you might have a fantastic application. An academic might really want to do your research or support your research, but it might cost also £300,000 to get the machine for you to start your research. So do check and make sure that what you want to do could be supported by the department. And in some cases, the research topic or the title is actually already fixed, because it's a studentship you're applying to. The studentship will say it's a research topic in this. And what you need to do, even though the topic is already defined, you still need to interpret what that means to you, right? So put in a meaningful topic. Proposed supervisor. Everything up here is what you would do if you were not on site. So you check the staff pages, look at their recent publications, make sure that you're actually identifying someone that has published in the area and is using methods and techniques that you're interested in learning. And ideally you would choose and try to find 2 or 3. Don't just, if you give 1, that's fine. We'll try to send that to that supervisor to consider. But if you choose 2 or 3, then it just gives options for that application to be considered by more than one. But what's really nice is because you are here today, our academics are going to be by stands in the IEB atrium, so you can meet with them, speak to them, you can explore what they're interested in, talk with them about your ideas, and that can actually help shortcut who those people that might be a good champion for your research would be. In terms of CV, if you put a CV together, you'll know that essentially it's everything. It's capturing your entire academic journey, all the awards, all the talks you've given, all posters and presentations you've delivered, any accolades that you want to point to. You can also put down clubs, societies, volunteering, things that you're involved in that show that in some cases you might be quite active outside of just pure education. And anything else that really you think sets you apart. We're just trying to capture who you are and what your journey has been up to this point. Transcripts, it's just, you can check their entry requirements for all the courses, but at least what you will need is a strong upper second class degree, okay? The other thing is that because we see your transcripts, maybe they're not uniformly, A's down the board, right? I can remember mine where I had one course that was not one I'm very proud of. But I did not propose to do research in that course. So they, of course, wouldn't question my application by saying, why would you like to do research in this when you did very, very poorly in it? So that's what I mean, is what were your best modules? Do they actually support your chosen research topic? Or are they going to seem a bit of an outlier and say, why would you want to do mechanics if you struggled in mechanics in your undergraduate degree? Okay. Reference letters, only one of them needs to be from an academic, and we often get many questions about, well, I don't have anyone that I could speak to about reference letters. There's actually quite a few people that have been involved in your academic journey. These can be a course lecturer, right? This can be undergraduate project supervisors, academic tutors, mentors. If you've done an internship in the university environment or even in industry, then them, of course, they can write a letter. Or even a former employer. But most importantly, it's important to find someone who can speak to your capabilities and your potential as being a postgraduate student, right? But only one of them, of course, needs to be from an academic, okay? And the last is, and there'll be more information online which talks about what's required, but depending on the course, you may be asked to construct a research proposal. If it's a research proposal, what we're really trying to see is your ability to look into the open literature, because you won't necessarily have access to closed literature behind a paywall, for example. But are you able to look into the open literature? Are you able to formulate some ideas around a research topic and put together a plausible proposal? Meaning this is something that could be supported and something that might actually lead to the answers that you're trying to get at, right? To solve the question that you're posing, okay? By equivalent, what we also mean is sometimes it's a statement of purpose, and that's going to be more of what was your educational background and why are you compelled and really motivated to do a postgraduate degree in this, for example, this CDT. Okay. So hopefully that's all clear. But as I said, most of this information is online. We will have a stand over just adjacent to us in LR3 where you can speak to our admissions team. So if you have any specific questions and want some clarifications, we've got people throughout the day that can speak to them. Okay, so what sort of funding is available though? So we do offer studentships. Now studentships are cases where we've been asked to find a student to do a specific project, right? So we have funding. We hold it in the university and we'll advertise these. And these will either be advertised one-off. So if there are, for example, industry-funded studentships, these will be on a single topic looking for one student. There'll be a very nice write-up, about half a page, that clearly defines what that project is. And that will be posted both on our website as well as usually Find a PhD or Jobs AC UK. Okay? Now, they will be funded at different levels. So some cases they will clearly be for home students, and I'll say not home students, but home fee level, right? So they'll only reimburse the home fees. Or in other cases, we might be so lucky to actually have funding to fund an overseas student. But those will be clearly explained on the respective adverts. Okay. There's other sort of structures where we can fund, where essentially funding is available. So through the CDTs, and this is why they're quite coveted, is that those CDTs, remember, these are cohort-based training programs where they actually have studentships as well. So when you apply to a CDT, you're also then applying for one of their studentships. So if you're accepted, then it would usually cover home fees at that level. In very minute cases, there's also limited capacity to fund an OS student, so there's some restrictions. But the point is that this is then around a thematic topic, and while you're on the CDT, you can slightly specialize within the domain of that topic. There's also then IDLAs. Now, IDLA stands for Industry Doctoral Landscape Award. This is funding that's given directly to the university from UKRI, our research councils. And the way that, sorry, I said that the wrong way around. It's given directly to an industrial partner who then gives it to the university, sorry. And what the IDLA then allows, it allows industry to only have to put up a third of the funding, and then the rest of the funding comes from the research council. But what's really nice about them is that it involves a 3-month placement at the partner site, right? So it gives a really good opportunity to sort of trial working with a company and actually work with them through the course of your research, but also often cases at the end, although it's not guaranteed, but there's a very strong likelihood that you could seamlessly then enter employment in that company after your DPhil. These will cover fees at the home level as well, all of these with a stipend and limited capacity to cover overseas, or limited restriction overseas. But in order to see what, I guess, studentships are available, you can find those on our engineering website. You can find the CDTs on the courses that we offer. And yeah, both of these would always be posted on here and findaphd.com. Okay. We also have internal funding, so that's external funding provided to the university, but there's also then internal mechanisms to award scholarships to the most promising scholars that apply. Our top scholarship is the Clarendon, and these will cover fees at the OS level as well, right? So everyone is eligible for a Clarendon. And these are decided towards the beginning, February, March of any admission cycle. You don't have to do anything specifically to apply for Clarendon. Just by applying for a DPhil or applying for a postgraduate degree here in the department, you are automatically considered for these awards, right? And that's true for any of these awards that actually are here, is that you don't have to specifically say, consider me for this. You will be put forward by the supervisor that you've applied to. We also then have limited capacity to support home students within the department, but I say limited, that actually isn't fair. Clarendons, we award around 7 to 10 scholarships a year. Department DLAs, we're probably awarding around 8 a year, so it's nearly the same number, but it is limited to home level fees, and so for that reason it's limited in terms of how we can deploy it. But again, you don't have to apply for them. These you'll be automatically considered for. And then the same for college scholarships. Colleges oftentimes like to pair with departments, offer 50-50 matched funding, or they'll offer a little bit of funding on the side just to help alleviate costs. And again, they have various eligibility. They might be trying to pursue some access initiatives, or there might be other eligibility criteria. And so we put forward the students that satisfy those eligibility criteria when those are made known to us. Okay, so again, you would be automatically considered for these, but there is a range of scholarships that you can see on the main Oxford website, and they have an entire list of those scholarships. Again, some of them which are specifically locked to applicants from certain countries or from certain backgrounds. Okay, so let's just very quickly then finish by talking about the admissions timetable. So admissions is actually open. So we opened on the 1st of September. This is where we are today, and the deadline for applying for a start in Michaelmas 2026 is the 2nd of December. Okay. When you apply again, you will automatically be considered for the funding that I've just previously outlined, and those funding decisions usually take place in February, and then we announce to the successful students towards the end of February, beginning of March. There is a second period of applying, right? So there's a second gathered field, which is in March. So if you don't make it in December, you can still apply before the 3rd of March. But the only real difference there is that all the funding has already been decided, right? So if you want to be eligible funding, and this is quite an important point, if you want to be eligible for any of the funding that we have internally, then you need to get your application in before the December deadline. Okay. I've said pretty much this already. This is something that really does catch out a number of our applicants every year. The December deadline isn't the deadline for you to hit submit in the system. It's actually the deadline for us to receive all your application materials. And the one thing on that list of application materials that you have very little control over is your references. And so what we strongly recommend is that you do leave time, a week, 2 weeks, for your references to be able to write their letters. You should contact them before you submit your application, let them know that you're nominating them, ask them how long they'll need. But yeah, so if you click submit, once you click submit, that will trigger emails to your referees, and then they'll have as long as it takes them to submit it. And if we don't receive the material in time, in some cases that means that application then gets bumped to the next gathered field, and then you may miss out on funding. Okay. In terms of decisions, because we know that there's many universities in the UK and abroad, and in many cases our students are holding on to offers from other places. We aim to make sure that all students receive an outcome within 10 weeks of applying. Okay, but of course we always say, if you're suffering silently in dark and you really don't know what's going on, just reach out to our team. Right? We don't want to leave you uncertain of what's happening, but around 10 weeks, that's how long it takes for the applications to be processed, for us to get all the transcripts in, and before we can make a decision. Okay. Okay. Just before I move on to the next talk and show you what the schedule of play is today, I've got time for questions if there's any questions.